Okay, let's talk about adding fractions and mixed numbers. Mixed numbers are the ones that look like that. First thing you have to do is you have to get a common denominator. Once you get a common denominator, you have to get new numerators. Okay, once you get all of that done, you add your numerators, you keep the same denominator, you add the whole numbers, change it to a mixed number if it came out improper, and always reduce. Now this looks like a lot. It's a lot of steps, but it's not difficult. It's just a lot of steps, okay? So hang in there, we'll get through this. Okay, I'm going to leave, I was gonna try to keep this up so we could refer back to it, but I'll just keep it off to the side for right now. Okay, so the first two examples, we have common denominators. So you cannot add two fractions that are not the same. Like I can't add something that's cut into that many pieces to something that is cut into that many pieces. It just doesn't make sense. Because like if I have 4 of these, but then I have the same amount of squares and another 4, then I can add those two together because it's 8 out of the same amount of squares. I can't add something that's split into tenths to something that's split into fourths. Okay, everything has to match up in fractions for addition and subtraction. I don't know if that made sense. Hopefully it did. Okay, so the first thing we notice here for the first example is they have the same denominator, so that's good. So all we have to do is, we don't have to get a common denominator. We don't have to get new numerators. We just go straight to number 3. Add the numerators. So 5 plus 1 is 6. Keep the same denominator, which is 7. It did not come out improper, so we don't need to change anything. And it cannot be reduced, so this one is done. Okay. All right, the next one has common denominators as well, so we don't have to change anything. So we can skip rules 1 and 2 and go straight to 3 where we add the numerators. 3 plus 1 is 4. Keep the same denominator of 16. It did not come out improper, but it can be reduced. We can divide them both by 2 or 4. Let's go with the higher number. 4 divided by 4 is 1. 16 divided by 4 is 4. Keep in mind, if you did the 2, that would give you 2 8ths, and then that could reduce again by 2, which takes you down to your 1/4. Okay, third example. Excuse me. Third example is one of those that does not have a common denominator. So I cannot add something that is in 8ths to something that is in 6ths. Okay, they have to be the same whole amount of pieces. So the first thing we have to do is get a common denominator. So what I like to do, excuse me, is put the problem one on top of the other. So they're side by side. The reason I like to do that is because we're going to create a new fraction here and a new fraction there. So it's nice to keep them side by side. So what you ask yourself is a number that both 8 and 6 can divide into evenly. And I always look at my smallest denominator, which is 8. And I say, can 6 go into 8? And the answer is no. So I know that it has to be higher than 8. So I think of all the factors of 8. All the multiples of 8, like all the numbers that 8 can go into. So those numbers would be 8 can go into 8, 8 can go into 16, 8 can go into 24, 8 can go into 32, 8 can go into 40. Okay? Of all of these numbers, is there a number that 6 can also go into? And the answer would be 24. So I'm going to use 24 as my common denominator. So what we are doing is we are expanding this fraction and this fraction up so they have the same denominator. We're expanding them to 24. So if you expand the bottom, you have to expand the top. So you ask yourself, what can you multiply by 8 to get 24? And the answer is 3. So then you take 3 times 3 and get 9. What do I expand 6 by to get 24? Answer is 4. And then 1 times 4 is 4. So that's step 1 and 2. Step 1 is get a common denominator. Step 2 is get your new numerators. Now I can add these because they are in the same amount of whole pieces. They're both out of 24 pieces. 9 plus 4 is 13 over 24. Added our numerators, keep the same denominator. It did not come out improper because the top number is not bigger than the bottom number, and it cannot be reduced. So this one is done. Okay. Next one. All right, so this one I have 4 plus 9 and 2/7. So think about if we have decimals, and let's say we were adding 4 plus 7 and 8 plus 2, 3. If this was an addition problem, you would just bring the 3 down. Same with fractions. Since it's addition, you just bring the 2/7 down. You don't need to get a common denominator because I don't have another fraction. Just bring it straight down. Add your whole numbers, which is 13. It cannot be reduced. That one is done.